Hello friends, this is Software Engineering Fundamentals. Nature of software, software engineering principles, the software process and software myths. These are the points which we have discussed in our today's lecture. The process models. There is a generic process model. In that also prescriptive process models we have to learn in this topic. The first one is the waterfall model, incremental process, that is simply we called it as a RAD model, evolutionary process model, unified process model, and concurrent models. These are the prescriptive process models we are learning in this session. Advanced process models and tools. In that, agile software development. Agile methods, plan-driven and agile development, extreme programming practices, testing in XP, pair programming. Friends, introduction to agile tools, in that Jira and Kanban. These two are we are learning. The case studies, in that an information system, that is mental health care system. These are the case studies. The software engineering fundamentals, in that nature of software, software engineering principles, the software process and software myths. These 4 points we have to learn in the software engineering fundamentals. Next, the process model, a generic process model. Friends, prescriptive process models, in that these 5 models we are learning. First one is waterfall model, incremental process, that is RAD model, evolutionary process model, unified process model, and concurrent models. The advanced process models and tools. Agile software development, agile methods, plan-driven and agile development, extreme programming practices, testing in XP, pair programming. These are the advanced process models and tools. Software engineering fundamentals. Nature of software, software engineering principles, the software process and software myths. These 4 points we have to learn. First of all, number 1, the nature of software. Friends, software plays a dual role, that is, it is a product and at the same time the vehicle for delivering the product. This is the nature of software. Second, software is an information transformer. That means producing, managing, acquiring, modifying, displaying, or transmitting the informations. For example, Microsoft Office, Paint, PDF, Creator, Media, Players, etc. These are the examples. Friends, as a vehicle to use to deliver the product, operating system, the Windows XP and Linux, etc. are the operating systems used to deliver the product. Software tools and environments. For example, Visual Studio 2008, NetBeans, Eclipse. Defining the software. This is the definition of software, that is, software is a instruction, data structures, and descriptive informations. In the instruction is a computer programs that when executed provide desired features, function, and performance. Data structure. In that, data structure enables programs to adequately manipulate information and the descriptive information in a hard copy and virtual form that describes the operation and use of the programs. This is the definition of simple definition of software. The nature of software. First, system software. System software is a collection of programs written to service other programs. For example, compilers, editors, assemblers, operating system. They establishes communication with the hardware. In the nature of second software, number 2, application software, that is the stand-alone programs developed for specific business needs. This software may be supported by database system. Friends, in the application software, we take an example as a Microsoft Office media player. Number 3, that is engineering scientific software. That means these software are based on complex numeric applications used as a tools for special purpose. For example, MATLAB, Vika, Scilab controls, features, and functions for end user and for the system itself. For example, robots, drones. The number 5, that is web applications. It contains web pages that can be retrieved by a browser. The web pages can be developed using programming languages like Java, PRL, CGI, HTML, DHTML. Number 6, artificial intelligence software. It is based on knowledge-based expert system used in robotics, expert systems, image and voice recognition, artificial neural networks, theorem, providing and game playing. Friends, there are many software myths. First one is management myth, customer myth, partitioner myths. These are the common myths in the software. First, that is management myths. We already have a book that's full of standards and procedures for building software. But won't that provide my people with everything they need to know? Or the members of an organization can acquire all the information they require from a manual which contains standards, procedures, and principles. This is the management myth. But the reality is that standards are often incomplete, inadaptable, and outdated. Next, developers are often unaware of all the established standards, and the developers rarely follow all the known standards. This is the reality in the management myth. Number 2 myth, if we get behind schedule, we can add more programmers and reduce the time gap. But the reality is that adding more manpower to the project which is already behind schedule. Further delays the project. Friends, the new workers take longer to learn about the project as compared to those already working on the project. The third software myth, that is, if I decide to outsource the software project to a third party, I can just relax and let that firm build it. No, but the reality is that outsourcing software to a third party does not help the organization. That means which is incompetent in managing, controlling, and maintaining the software project internally. This is the third software myth. Friends, here the customer myths. In the customer myth number 1, that is, brief requirements stated in the initial process is enough to start development. The detailed requirements can be added at the later stages, but the reality is that starting development with incomplete and ambiguous requirements often lead to software failures. Instead, a complete and formal description of requirements is essential before starting the development. Adding requirements at the later stages often requires repeating the entire development process. This is nothing but the customer myths. There is a second myth, that is, software is a flexible. Hence, software requirement changes, but it can be added during any phase of development process. This is the software myth, that is, software is a flexible. But friends, the reality is that incorporating change request earlier in the development process cost lesser than those that occur at later stages. This is because incorporating changes later may require redesigning and extra resources. This is second software myth. Partitioners myths. In that, once we write the program and get it to work, our job is done. But reality is that 50% to 70% of all the efforts are expended after the software is delivered to the user. The only deliverable work product for a successive project is the working program. To make the project successful, the documentation and software configuration also plays crucial role in the software development process. Number third, software engineering requires unnecessary documentation which slows down the project, but the reality is that proper documentation enhances quality, which results in reducing the amount of rework. Number 4, that is, software quality can be assessed only after the program is executed. But the reality is that the quality of software can be measured during any phase of development process. By applying some quality assurance mechanism, one such mechanism is formal technical review that can be effectively used during each phase of development to uncover certain errors. This is the reality. in the software myth.